Good afternoon, everyone. I'm Sangeeta Suresh from Bridge to India, and I would like to welcome you to RE Views, a platform where we host live sessions with experts and deep dive into some of the key areas in the renewable energy sector. Our topic today is robotic automated cleaning solutions for the solar sector. It's extremely pertinent given that a large share of the existing and under construction projects are in dry regions where both water and manpower resources are scarce. So today, joining Vidul Chadda, Associate Director, Consulting at Bridge to India, is Mr. Amit Singla. He is the Vice President of Operations at Ecopia, one of the leading robotic cleaning solutions providers in the world. Welcome to our session today, Amit. Thank you for sparing your time with us. So very quickly, today's event will be an hour long, and it will end in a Q&A. If you have any questions, I request you to please type them into the box at the bottom right corner of the webinar panel in front of you. So that is all from me. Over to you, Mridul.
Thank you, Sangeeta. A very warm welcome to you, Amit, and the attendees as well. I think as most of us would be aware, Ecopia is a world leader when it comes to robotic cleaning solutions, and the company has been a first mover in this technology. So, Amit, just to kick off things, if you could share the journey of the company, the growth story of the company in a few words, and your local presence in India.
Sure. First of all, I would like to thank you for inviting me for this session. About Ecopia, we are not a very old company. We are still very young, founded only in 2013. And soon after founding the company, we started our operations in India in 2016. So we have been present in India since 2016, and we have an installed base of more than 2.5 gigawatts in India. And we have a very strong local presence here, starting from manufacturing to, post-sale support. We have our own team of more than 80 engineers who are supporting the operations in India. And in fact, over last few years, looking at the various kind of projects coming up, we have been adding to our portfolio of products, different variety of robots. So we started with just one robot, which we used to call as Ecopia E4. And now we have in our portfolio a variety of products, Ecopia E4, Ecopia T4, and now the latest one in our stable is Ecopia H4, which is a product which is suitable both for fixed tilt applications as well as trackers. In India, our clients include all the leading names in the industry, starting from NTPC, SoftBank, Adani, Renew, Fortum, Azure, all our clients here.
Okay, you mentioned about some of the latest technology offerings. We will come back to those later on. But if you could very briefly tell us about the most advanced technology solution that you currently offer, and how it is different from the other offerings available in the market.
Of course. So our latest technical offering is Ecopia H4, which comes with a patented bidirectional helix cleaning technology. So the cleaning method remains same as our previous robots, E4 and T4, as the microfiber, which is very soft and gentle cleaning method for solar panels. It comes with a this bidirectional helix technology. It moves horizontally but still cleans vertically. And when you move from one direction to the other, the direction of the helix also changes automatically. So in addition to effectiveness of cleaning, what we always offer is safety and reliability. That is our core, and which is what we are following with this latest offering of H4 as well. Some of the big advantages of this are we are using very safe and reliable batteries here, which gives up a range of almost up to 2 kilometers long. So arrays which are up to 2 kilometers long can be cleaned with a single robot on a per day basis, which reduces the capex cost by a significant margin. And also it requires very minimal auxiliaries. The docking station needed for it is very narrow as compared to our previous offering. So the additional structure requirements also goes down a lot. And it's designed with keeping the latest trend in the market in mind. Like there are plants which are highly undulated, and this robot, it comes with very superior maneuverability. It has, it comes with a four-wheel drive, and it can maneuver any sort of undulations, and has a very flexible frame to work on this difficult terrains. And like all our other models, it is again cloud-based, connected, and completely autonomous in terms of having its own self-charging, self-cleaning solar module, which comes along with it. And of course, all our other offerings, which comes along with our cleaning solutions, like very interactive, smart dashboards, intelligent weather reporting, all are, same integrated with this robot. And one of the best features here is it's a very fast in cleaning. So when we are talking about say 2 kilometer long arrays, it needs to be fast as well. So it cleans at a very fast speed of 22 meters per minute.
You mentioned, Amit, you mentioned about uh, this new offering being able to work in difficult terrains as well, highly undulated uh, projects as well. If you could perhaps mention what kind of scale of projects is this technology and perhaps your other models as well most suitable for? So capacity range, if you could mention.
So, if we talk about our current portfolio, we have projects ranging from 5 megawatts to more than 500 megawatts at a single location. But if we look at economies of scale, it makes sense if we use it for projects more than 50 megawatts in general, because the product comes with a very robust hardware and software capabilities with advanced software analytics, weather input. So it makes more sense for large scale projects. And if we talk about our recent few years data, most of our new projects have been in the range of, 3-digit size only. So very few small projects are coming our way, and we are also looking more towards large scale projects.
Okay, okay. A very obvious question that many of the attendees would have: how does the robotic cleaning affect the production of a power plant? What is the kind of delta that any developer can expect if robotic cleaning is implemented?
Yeah, first and foremost, it is something which is replacing the manual water cleaning, which anyways is with this current size of projects, it's very unsustainable to do water-based cleaning in very large-scale solar power plants. But if we still compare it with the manual cleaning, that used to happen once in 15 days, once in 20 days. And when we move to autonomous robotic cleaning, we can clean the entire plant in a single day operation. So definitely that gives a big generation delta over our conventional way of cleaning. But how much that delta is, it depends a lot on location as well and the kind of technology which is gone into the plant. So we have seen a delta anywhere between 1% to going up to 5% in certain cases. One of the major factors which comes into place during sandstorms or during dusty environment, like if we talk about India, especially area in Rajasthan, arid, dry area. So during summer times, there are very frequent dust storms. If you are doing cleaning using water, even after dust storm, you'll be able to clean the plant not before 15-20 days, because every day you're just cleaning a small portion of the plant. Whereas with the robotic dry cleaning, you can clean the plant even within a couple of hours of the dust storm. So that gives a big advantage over conventional methods, and even a single dust storm can bring down the solar plant output by more than 30%. So if we count in such factors, the gain can vary anywhere. And average, it's not so uncommon to see a gain of 2 to 3% on an annual basis.
Okay. So, Amit, you talked about the benefits, the generation delta that can be expected. If you could share some details about the cost related to these benefits that a developer stands to gain from, and how the cost benefit matrix has changed with the evolution of the technology that you just mentioned.
So, as we all know, and we are following, a lot of developments are happening in the solar space. Solar module prices and their sizes have been varying a lot. And as we are moving towards bigger and bigger solar panels, the overall balance of system costs are going down. And with the advancement in technology, there have been some improvement in cost of robotics as well. And a major factor to that is economies of scale, because now more and more project owners are adopting robotic solar cleaning. But if we compare it with the trajectory which is being followed in, say, other components of the solar power plant, the cost reduction is not in the same proportion. But thing to note here is if we look at the overall expense of a solar power plant and initial capex, if we talk about, the cost of robots is less than 2% of the overall cost of the plant, and having any significant price reduction there is not going to be a major impact on the overall plant costs. So I believe rather than focusing more on cost, the focus should shift more towards safety and reliability of the operation.
Okay. Okay. Um, You mentioned about some of the additional features, add-ons that your company offers, for example, data analytics, smart dashboard as well. Before moving into those add-ons, I would like to understand how autonomous the robots actually are, and is there any human intervention required at all in the operation?
So our robots are completely autonomous, completely automated. All our robots are connected to the Ecopia cloud, and all the cleaning operations happen automatically at the time desired by our client. So they can, set the timing that, say, a few minutes after or before the sunset, they want cleaning operation to happen. So all the robots come out of their docking stations, do the cleaning operation, and come back to the docking station on their own. So in this entire process, there is no manual intervention required at all. The only manual intervention or the presence which we have on ground is only to do predictive and preventive maintenance activities on the robots, so that we can, maintain the committed rigorous SLAs that we offer to our clients. So in that sense, for our day-to-day operations, there is no need of a single manpower on site. In fact, some of our projects where we have thousands of robots operating at a single site, it's just one engineer which is there just to take care of any untoward incident which might happen, or just to take care of basic preventive and predictive maintenance needs.
Okay. And the one engineer that you mentioned, is that engineer specifically stationed for the robots, or the general O&M team present at the project itself can take care of any O&M that the robo systems may require?
So far, we have been maintaining our own team of on-ground engineers, field engineers, just for robotic maintenance perspective. So it's not still the maintenance part is not handed over to the clients. What we believe in, when the clients are investing in this technology, we should be a partner with them for a long-term period, the entire life of the project, so that they have a peace of mind. The kind of technology that they are buying, the kind of robots that they are buying, they should not be worried about their maintenance. They have other things to worry about. They can leave that part to Ecopia, and that gives them a complete peace of mind that the robot that they're going to buy, it's going to be serviceable for the entire life of the project.
Got it. Got it. Amit, you mentioned about cloud computing and data analytics. What kind of data does the robotic cleaning system generate, and what happens to the data after that? What kind of analytics do you run? Do you communicate any? Do you recommend any changes to the project developer, to the O&M contractor?
So as of now, the data that we are collecting and sharing with our clients is all related to the cleaning efficiency or the operating details of the robots. We have very interactive dashboards for our clients where they can see the weather data and its impact on robotic cleaning, and for each single day how each robotic unit operated, for how much time it took to clean the entire plant, and if any specific unit is not behaving the way it should be. So each and every drill down can be seen by our clients, and accordingly, our team is also looking at that data very specifically. But going forward, the kind of cloud infrastructure that we have built, which is backed by Ecopia AI, since robots are scanning each and every part of the solar structure, we can provide lot many other inputs to our clients which we are not monetizing yet. So our robots are equipped with different kind of sensors. They can monitor tilt and slopes of different structures. So structural integrity, if a structure is getting damaged or shifting from its original position, everything is captured by the robot sensors. So these kind of inputs can provide a lot of predictive maintenance inputs to our clients in future, and that becomes more important when we move from fixed tilt to tracker based applications, where the structure itself is very dynamic. It's not a stationary structure, it's moving on an everyday basis, and it might being a structural element, it can have its own failures. So our robots, with the kind of sensors they have inbuilt on them, they can track those kind of changes in the structure and share that information with their clients or their maintenance teams, so that they can take uh, in time action before the actual failure happens in structure, and which might eventually lead to loss of generation if we have to disconnect a few panels to make all those changes once the structure is actually broken. In addition to that, there are various other possibilities, which we are already doing, since we are scanning the whole array on a daily basis. If any modules are broken or if any modules got moved because of winds or storms, so all those kind of inputs can be captured very easily. And in future, there can be some attachments which can do, say, a thermal scanning of the plant, showing if there are any hotspots or any future problems which might occur with the solar panels. And all that is possible because the robots are scanning the entire array on a daily basis.
Okay, okay. And just out of curiosity, for thermography, for example, uh, would you be able to simply change the design of the existing product, or would that be a modular equipment that can be included in the existing design itself? Any R&D that you have done, or any thoughts about it?
So these are modular components which can be added on top of the existing robots. But any addition, any modules, they come at an additional cost. So if
Right.
our clients are inclined and they show interest in that, we have some additional modules which we can add on top of our existing robots. And any which
Okay.
ways, the data from the robots is going to the cloud, and it's integrated with the dashboards that we are showing to our clients. And one other, interesting possibility is right now there are different kind of equipment being used in the solar power plants, security cameras, your tracker SCADA, inverter SCADA. So all of these are right now not so integrated on a single platform, but we have the possibility of bringing everything onto that Ecopia cloud and share very interactive dashboards with our clients. And at a single point, they can see all the different areas of interest for a developer.
So as far as I can understand, it's not just about the hardware, it's about the data, the software as well.
Yes.
That the kind of features that you are offering.
Yeah, exactly. So on top of that, we have partnerships with multi-billion-dollar tech companies, and we are using their features onto our dashboards like Salesforce, Tableau, Snowflakes, IBM weather data. So we are using all that and running our AI engine behind that to provide meaningful insights for our clients.
That's great to know. You mentioned briefly about the H4 offering, the latest product in your portfolio. Could you elaborate more about its capabilities and how it fits in the Indian market?
Of course. So, as we all know that now the solar plant sizes are going up and up, and there's a lot of pressure on the cost side. So earlier, like we talk about 5, 6 years back, developers used to do leveling of the land, some grading to maintain some slopes there. But nowadays, we are all following the landscape, the natural gradient. So this H4 robot is capable of maneuvering in all sort of gradients, and it has a very flexible frame to navigate in difficult kind of slopes. And we have designed it keeping in mind the brownfield market as well. So where you can connect the things which were earlier on manual water cleaning, but with minimal structural intervention, we can use H4 robot there. And as I earlier described, its features like it's very fast. It's comes with its bi-directional cleaning, which involves very less time spent on the panel. So it will clean from east to west on one day and west to east on the other day, and that way we are reducing time spent by the robot on the modules, enhancing the safety and reliability capabilities.
Okay. Okay. Uh, we talked about complete automation of the robotic systems. We have been hearing a lot about the lift and shift or pick and place solution. Could you share some details about it?
Yes, many of our clients are also talking about it, lift and shift, and it's like the overall objective is to reduce the capex which is going on to it. But we need to, consider some of the other factors. This lifting and shifting or pick and place, whatever term we use, it's done by unskilled, untrained people, and it may lead to damages on solar panels when they're shifting it from one place to the other. And if by improper handling of the robot itself, it will cause some accelerated damages to the the robot parts also. So when we look at lift and shift arrangement, we need to account for these costs of extensive manpower or labors involved in doing this activity, because that also is a cost. So we are looking at the lesser capex, but we are increasing the opex on the other hand. And then
Yes.
because of improper handling, it will lead to warranty issues, breakage in modules. So bottom line is the cost could be eventually higher as compared to going for a fully autonomous solution. But because of improper shape of land where some of the rows are really small, it becomes a necessity. And we are also open to offer this lift and shift arrangement on a for a small portion of the plant. But if we look at the complete plant and trying to save on capex, I don't think it will be a very wise decision to do so. Counting for this extensive labor cost involved, and as we see, the labor cost is increasing on a year-on-year basis with the rising inflation in India. So maybe a couple of years down the line, we will realize that the cost that we are spending in terms of manpower, we could have saved it if we had bought few more robots rather than employing so many people doing this lift and shift operation.
Right. Right. So Amit, we talked about the application of H4 in the Indian market. Now the Indian market itself is changing. A number of developers are now looking to install bifacial modules. So is there any specific robotic cleaning solution available for bifacial modules as well?
So Ecopia has installed multiple locations with bifacial modules, and we have been operating on bifacial modules for quite some time now. But the thing is, we are cleaning only the top surface, and based on the feedback and actual inputs received from ground, there's not really a necessity to clean the backside of the modules, because the dust tend to itself, fall down because of gravity. And maybe it might require the cleaning on the rear side once every few years. So that doesn't really, creates a need for a robotic solution for the backside cleaning of the bifacial modules. So from robotic cleaning perspective, it's more like, any other modules. And we have been operating in such plants for a while now. We have, I think, more than 3, 4 such installations with bifacial modules globally.
Okay. And what about rooftop solar systems? Does your company offer any solutions for rooftop solar power systems as well?
So since our inception in 2013, our focus has always been on large-scale ground-mounted systems. And the kind of solution that we have built, this robust hardware, software, weather inputs, and the kind of SLAs that we are offering, and this team of engineers that we have, it doesn't really make economic sense to use that in small rooftop solutions. So as of now, the focus is only on large-scale ground-mounted systems only. And as I iterated earlier, if we look at our last couple of years sales data, most of our projects have been in 3-digit size, upward of 100 megawatts only. So we see very few inquiries or very few installations which are smaller sizes.
Oh,
So the cost of the solution will not justify using it in rooftop installations, which are typically, smaller in size.
right, right, indeed. Uh, I would like to know the latest market trends that you have seen in the Indian solar sector with respect to what kind of developers are adopting robotic cleaning solution, what has been the geographic spread. I believe most of the projects would be concentrated in Rajasthan, but is that really changing? Are new regions, are developers in new regions also adopting robotic cleaning? Then there is a point regarding sustainability. Companies are looking to reduce their water consumption, water footprint. So, if you could briefly share some of the market trends that you have seen in the Indian sector.
Sure. So, as you rightly said, the intuitive guess is that it will be more useful in dry and arid regions. But if we look at our installed base in India, we have installations starting from North India to going all the way up to Tamil Nadu. So we have installations all across India, and all our clients are using robotic cleaning irrespective of the region, whether it is in Rajasthan or Karnataka or Tamil Nadu. And it's very closely linked to the point that you brought up about sustainability. So even though the area or the kind of soiling may not be as in the case of Rajasthan or Gujarat, but the water availability, and especially if you're talking about very large scale solar power plants, is a challenge for all clients. And we together in the renewable energy sector, we are working towards a sustainable environment. So it doesn't really relate that we use water just for cleaning modules. As it is, there's a water scarcity. People are not getting enough water for other basic necessities. And at the same time, if you're using water just for cleaning the solar panels, it doesn't make really a sense. And this, apart from this, economically also, most of our clients which have gone for robotic cleaning in southern states in Pavagada, Karnataka, or Tamil Nadu, they are seeing a good generation impact as well as compared to that bi-monthly water cleaning if they go for robotic cleaning using Ecopia robots. So irrespective of the location, we are seeing the deployments all across India. And in terms of other trends which we are seeing right now is earlier the use of trackers in India was really limited, and now more and more developers are going for trackers, and mostly because of the increasing cost of solar PV modules. So with the same capex, you get higher generation if you're using trackers. So there as well, we are fully integrated. Our H4 robot works pretty well with both fixed tilt and tracker applications. And this wide portfolio of product that we have, as I described in the earlier beginning of this conversation, Ecopia E4, T4, and H4. So we cover all sort of plants which are coming up in India and globally. Interestingly, we are doing one such project in Rajasthan with one of our key clients, where we are deploying all three robots in a single site. So it's a mix of E4, T4, and H4 all going to the same site, and it's all considered counting for the lower, the best cost solution for our customers. So for smaller rows, we are offering our T4 robot, and for longer rows, we are offering our H4 robot, and for the fixed tilt, the client opted to go for E4. So it's going to be a very interesting case study once the plant goes live in a couple of months from now.
Okay, yeah, very interesting indeed. Uh, there is a question as well in the chat box, which somewhat relates to uh, what you just mentioned. So this is regarding what kind of design constraints, considerations does a developer and Ecopia itself need to take into account while offering the different kind of uh, solutions, E4, T4, and H4. So I think this your response answers that query. Uh, Amit, we have seen for the last several quarters, especially in the module supply chain, there have been significant supply constraints, logistical constraints as well. Have those supply constraints and challenges affected your production as well?
So, if we look at the global supply chain scenario, semiconductor shortage has been impacting most of the industries. But thankfully, because of our robust pipeline and continued order flow, we have been able to maintain continuous supplies of the required components for us. And it has not yet caused any significant problem to us. But yes, if we look globally, this is one major issue, one major bottleneck, which is impacting multiple industries. But our long-term partners with whom we have, some good terms, have been reliably supplying us the components that we need. So, as such, on us, there is no much significant impact.
But have the production costs been impacted in any way?
Production costs are getting impacted because of increased logistics cost. So when we are importing any goods from outside India, the lead times have increased. The cost of bringing in one container by ocean, it has gone up multifolds. But slowly and steadily, the things are coming back to normal, and hopefully with the kind of scale that we are seeing, we should be able to manage. And I would like to bring it to your notice that the manufacturing facility that we have, so world class mil spec manufacturing facility in India, and we are using it for our all global needs. So irrespective of whether the robots are being used in India, Middle East, Europe, Latin America, North America. Everything is getting manufactured here. So this helps a lot, and this brings in that element of reliability, repeatability, because of this mil spec military grade operations in the facility. Same facilities, being used by defense players, like NATO, IAI, etc.
Okay, very interesting. Uh, what kind of considerations must a project developer take into account if he's going for a robotic cleaning system?
So first and foremost, there's like with most of our clients, we start working at a very early stage itself when they are designing the layout, when they are designing the MMS structure, so that it is well integrated with the robotic needs. And that helps in reducing the overall cost for the project and getting the best LCOE to our customers. If we look in past all the lowest bids, starting from like 4.34 back in 2016 to 2 point something in current terms, all have been with Ecopia. And the way it works is we start working with our clients at a very early stage, which helps in bringing down the overall structure costs as well as the number of robots required. So our team works in tandem with the client engineering team and their EPC teams to design the optimal layout, which reduces the number of robots required and the kind of additional weight of structure which might be needed to support the robots. So this way, we have been working very closely with our clients starting from a very early stage. But considering that still a large percentage of plant which were installed earlier are still on manual cleaning, and many of our existing clients who own such plants and want to shift towards robotic cleaning, we kept all those considerations in mind while designing H4. It's like very well suited for adopting any brownfield plant or doing any retrofitting on a brownfield product to make it suitable for a robotic cleaning.
Okay. But what are some of the important factors, specifically with respect to brownfield projects, that the developer or Ecopia needs to take into account? For example, one could be the slope. Uh, any other important factors that you consider?
Yes, slope is one factor, and that is also manageable with our new offering. It has very high maneuverability capabilities. But one more thing which comes to a mind, which everyone needs to understand, that the way layouts have been built, the roads are designed in the uh, plant. The ratio of robots per megawatt may be a little higher, and since the structure itself was not initially designed for robotic cleaning, there could be some additional retrofitting cost involved. But what happens is whatever extra money that we are going to spend in adopting the brownfield plant for a robotic cleaning solution, it gets all recovered with the increased generation or the delta which comes in after we start cleaning plant regularly with the autonomous robots.
Um, can you give any ballpark figure for the share of brownfield capacity versus greenfield capacity within India, if you have those figures handy?
Mm, If we talk about our current installed projects, out of 30 something projects, only three are brownfield projects. But if we talk about our current pipeline, almost I believe 40% of the pipeline constitutes of brownfield projects.
Okay.
And we are
Okay.
seeing an increasing trend, or more and more of our existing clients and some new clients want to adopt for their brownfield projects. And especially with the, realizing the benefits of robotic dry cleaning, the kind of additional generation it offers, and a reduction of your O&M expenses in terms of water cleaning.
Right. Right. Amit, you mentioned about the pipeline. If you could share some more details about what your pipeline looks like, and perhaps pipeline projects which are geographically spread as well. So newer regions being added to the pipeline capacity.
Sure. So when we started Ecopia, it started with Middle East in Israel. We our first very first projects were in Israel, and then the next stop for us was India. And if we talk about our current pipeline, still, almost 70% of it is coming from India. But since last couple of years, we have been, looking very aggressively in other global markets. As we speak, we already have our installations in other Middle East countries apart from Israel, in Dubai and some other places, and in Latin America, in North America, and some small installations in Europe as well. So this the global footprint is increasing, and we are seeing more and more adoption coming in from geographies other than India. And within India, as I said, that it is not restricted to any specific state or any specific geography. We are seeing interest and installations across India, starting from not like our very first or one of the first few brownfield installations was in Dadri, which is a very interesting use case. It's an NTPC plant situated inside or middle of a thermal power plant. So and it is situated on top of an ash pit. So there is ash on the ground, ash in the air. So before deploying Ecopia, they were cleaning the plant once every other day, like every alternate day, they were cleaning the plant using water, because that was the level of soiling because of the fly ash. And post installation of Ecopia robots, it works beautifully without any single drop of water needed for cleaning the plant. So from Dadri to Tamil Nadu, across geography, we are seeing installations in India.
There is a question regarding the type of dust around the project as well. So in Gujarat or Rajasthan, the soil is very dry, so it may be easier to clean it. What about areas with sticky or clay soil? Uh, how efficient are the robo cleaning solutions in such cases?
So we have a real case scenario of Tamil Nadu, couple of plants that are there. The soil there is very clean, it's black cotton soil, and humidity levels are also generally high in that region. And we have been seeing very efficient cleaning using our soft microfiber there. And during the initial studies that we did there in terms of generation benefit, it's giving a much, attractive. I would not like to put the numbers here because the numbers were really good. So it's offering much higher generation as compared to water clearing. So with respect to experience with different kind of soils, we have seen it all across India, starting from Dadri, which is like fly ash. That also is not also dry, and there's humidity and moisture in the plant, and it cleans it pretty well. And then dry areas of Rajasthan and humid areas in coastal areas of Gujarat or Tamil Nadu, we are seeing good cleaning quality and very effective cleaning using this microfiber everywhere.
You mentioned Dadri, which is a very good example, not only uh, with respect to the dry ash where the project is, the dry ash bed where the project is actually located. Dadri, for the convenience of the attendees, I'd like to clarify that it sits within Delhi NCR, which we all know is a highly polluted area. So in that regard, also Dadri is a very good example that you have shared. Um, another question is what kind of weather proofing or IP ratings do the robo cleaning solutions come with?
So since the robots are designed for cleaning in an outdoor environment, so they're very much suited for any sort of weather. In Rajasthan, in peak summers, we are seeing weather temperatures going up to 55 degrees Celsius during the daytime. And whereas at the same time in winters, during night time, it can go as low as almost 0 degrees. And we are seeing different kind of sandstorms, other weather challenges, huge rains, surprisingly in Rajasthan. So our robots are battling it all without any impact on their functionality or life of the components there. So it's well designed, well suited for all kind of climatic conditions.
Okay. Okay. What kind of warranties do you offer for your products? Amit?
So the robot comes with 2 years of warranty, but more than warranty, what is more important is that we believe in giving peace of mind to our clients. So we bundle a long-term service contract with all our offerings. So irrespective of the warranty terms, if something goes wrong with the robot, say 10 years down the line or 25 years, 20 years down the line, and if we have to replace the entire robot, we'll be doing it at our cost within those AMC terms. So warranty is not really that important when it comes to working with Ecopia's comprehensive maintenance contract.
Okay. There's a question regarding H4 model. Uh, how customizable it is with respect to the project requirement? I think you have answered this question um, quite a few times, but if you could quickly,
Sure, it's a very modular in nature. As I told that it comes with the four-wheel drive, so it can be customized for different kind of undulations that we might see on site. Second is the length or the width of the table. It varies different depending upon the module size, so that also is pretty customizable in terms of area that it can cater to. So we can cater up to 2 kilometers long arrays. So that also is very modular in nature. So all those key considerations which are there in solar power plants, we have taken into account, and it can be customized per the client needs.
okay. Then there are a couple of questions regarding the impact of the brushes, the microfiber brushes on the modules. Uh, I believe there wouldn't be much impact on the modules, but there's a question regarding uh, the structural sanity of the modules itself. Does the speed of 22 meters per minute does it have any
Mhm.
impact on the module structure itself?
Sure. So I'll answer the first question first regarding the microfibers. So it's a very soft, very gentle stuff. It's like the towels we use, and it's just touching the solar module glass, top glass only, and it touches it very gently. The only action that it is doing is just removing the dirt from top surface. So in terms of its impact on solar panels, it can be seen with the lot of long-term studies that we have done with reputed laboratories such as PI Berlin, where we compared the anti-reflective coating ARC, which comes on top of modules, with the cleaning using Ecopia soft microfiber-based cleaning versus manual cleaning. And in terms of doing this accelerated long life testing, even after 25 years simulation of cleaning, the ARC remains intact, which is like very gentle, very fragile coating. Whereas in case of comparing it with manual cleaning, it goes away or starts breaking with the first five, six manual cleaning cycles itself, because there is no control of pressure, no control of the way it is going clean. But the robot is a machine. It always applies the same kind of pressure uniformly. It cleans. And coming to the second question about the speed of robot on the solar plant. So one of the very beautiful feature in our H4 is it maps the row. It when runs for the first time, it maps where the slopes are, where the undulations are, and it varies its speed accordingly. It's just like when we are driving on the road and we see a sign that there's a speed breaker ahead, we slow down our speed and then we pass over it smoothly. It's the same way with our H4 robot. So in the first scan, which it does slowly, it maps the entire slope gradient of the road. And in the next time when it is cleaning, it automatically slows down when it is coming, a step like this where it doesn't accidentally bump into the structure at a high speed. So these kind of safety features we have built into our software.
Okay. Okay. I
That is
would
that is
request
the brain behind the Ecopia AI that we call as. So this is what it does. It does an adaptive learning as compare,
right,
as soon as it starts operating for the first time.
right. I would
Second thing
request the
is
attendee.
that we have is, in case of dust storms or very heavy soiling, the robot can also activate a super duster mode where it, runs at a much faster rotation RPM and cleans that, heavy amount of dust which might come in after a sandstorm.
Okay, very interesting. I would request the attendees to type in any queries that they may have. There are a couple of queries regarding your manufacturing capabilities. One question is where the manufacturing plant in India is located, and what kind of local assembly or local content is used by Ecopia to manufacture the robots in India.
So our manufacturing facility is in Mohali, north of India, and it's there since 2016. And since our R&D is based out of Israel, so whenever we are making any new robot, the first few prototypes are made there. But as soon as we move into mass production in India, our immediate efforts starts toward localization. So in terms of our already existing two projects, E4 and T4, which we have been building or assembling in India for a while, the local content is like almost close to 80%. And this is the trajectory that we which follows once we get into that mass production mode. So there's a very high local content, and it's giving employment directly and indirectly to lots of Indian youth. And when we talk about, when I spoke about our 80 engineers team, that was excluding the manufacturing count because that's a separate facility in itself.
Okay. Okay. One of the questions is regarding the auxiliary power consumption requirement for the robots.
So, as I said, the robot is completely autonomous. It comes with its own solar panel, and not just this robot, all our other robots as well. So, we have our own solar panel which charges the robot battery during the daytime, and the same power is used by the robot while doing the cleaning after generation hours. So, we are not drawing even a single unit of electricity from the client premises or from the solar plant. So it's completely autonomous in that sense.
Okay. There is another question regarding the microfibers. What is the life of the microfibers and what kind of O&M charges can a developer expect with respect to the robotic cleaning systems?
So the life of microfibers is it's a washable material first of all. So the life is based on number of washing cycles. So every year we need to wash them off to keep cleaning at an optimal frequency. And each set of microfiber can sustain 3 washes. After that, it start losing its integrity. So, and this cleaning, replacement, everything is part of the O&M expenses or AMC fee that Ecopia charges, which includes all the consumables, be it batteries or microfibers or belts or any other part which goes into the robot. And the charges are typically, it's a function of the size of the project. So it's very difficult to tell right now, but as a ballpark number, I can say that the annual AMC fee, it's around 10% of the capex, close to that number.
Okay. Okay. There's another question. This is regarding the type of dust again. So cement industry. One of the attendees has a question regarding the cement industry. If the project is looking at robotic cleaning solution to address that kind of dust, because the attendee mentions they sometimes have to use chemicals to remove the dust particles from the modules.
Sorry, Mridul, I lost you for a few seconds, but if I have understood your question, it's about the application or use in cement industry, where there's a very fine settlement of dust
Yes.
particles or cement particles on the panels, and which over time get deposited and need to be cleaned using chemicals, and doesn't simply go off with water. So
Right.
we haven't tested it in such scenario, but I believe once you start doing daily cleaning with microfiber, then we don't really need any chemicals. This deposition, it happens because the cleaning frequency is low. You cannot really clean with water on every day basis, and that is why over time the sedimentation starts happening, and because of the sticky nature of these particles, it doesn't simply come off with water. But if we start cleaning it on a daily basis with microfiber, then probably this kind of problems may not occur. What I anticipate is in that case, maybe, I was mentioning that the cleaning frequency of microfibers is once a year. In that kind of scenario, we might have to wash microfibers maybe once in 6 months, or maybe even frequently. But I believe with the frequent cleaning, this problem can be addressed.
Okay. We have time for just one more question. So this is regarding the brownfield projects. So the question is, if a developer is looking to install robotic systems on a brownfield project, uh, would there be a requirement for strengthening of mounting structures or any other additional costs that the developer may have to bear?
So in terms of strengthening the structure, it may not be really needed if the structure is intact and it's of good quality, because most of the structures which are designed in India are designed for sustaining wind load of more than 140 kilometers per hour. And if you look at the weight of our this new robot H4, it is minimal. It's close to 45 kilograms, and that too is divided across 8 different load points. So from that perspective, it doesn't really need any strengthening of the structure. What additional part may be required is the bridging between two tables, because individual tables are separate in a brownfield project. So we need to bridge those tables together to make a continuous long array. And the second thing which will be required will be a small docking station at one end of the at the end of the arrays, where the robot will be resting during the daytime. And this robot is much narrower. Our first generation robot E4, it required a much wider docking station, almost 2.6-meter wide. And here we can manage with approximately half the width. So that kind of space is always available on the sides of the array. So only additional structure is the docking station and the bridges.
Okay. Amit, I'll quickly slip in one more question. This is regarding the payback period of the typical payback period for some of your offerings. Um, if you could share any figures regarding that.
Sure, it's a very interesting question, I must say, and it has come, almost at the end of the session. So the payback period is a function of, as we, broadly say, how much we are spending and how much in how much time we are going to recover that cost. The spend itself is depend on the array layout. If it is a very well-built plan and we can, cover the entire plant with say 2 robots per megawatt, then really the cash outflow will be very small or very meager. And whereas the savings or the income that it will be generating for the payback will be in terms of reduced water cleaning expenses and increased revenues because of the additional generation. So it's very difficult to put one number to the payback period because there are multiple levers to it. The plant layout, defining number of robots per megawatt, which changes drastically. So we have seen plants where per megawatt we have deployed more than 10 robots, but these were like really small pilot projects. And to a very optimal layout where per megawatt robot requirement is less than 2 robots per megawatt. So it varies a lot. And second is in terms of increased generation, that also depends on the geography of the plant. Third is about the revenue which this increased generation brings in. It depends on the at what tariff the plant is having the PPA. So
Right.
with all these factors in mind, the payback period can vary from say as low as 1.5, 2 years to maybe 5 to 6 years. So it depends on all these factors.
Understood. There are some more questions, but I think we have covered those in our interaction earlier. Amit, thank you very much for taking out time and speaking to us and very patiently answering these queries from the attendees. We will be sharing the recording with the attendees and also uploading the video on our website uh, for any future viewing as well. Amit, thank you very much. Uh, and we will now close the session.
Thank you, Mridul. Thank you so much for this interactive session. I really enjoyed talking to you and answering some of these queries. And thanks to all the attendees for patiently listening to us. And you can reach out to me on LinkedIn if you have any further queries. Thank you all.
Thank you, everyone. Thank you, Amit.
Thank you.